This is Kenneth Colin from RHK Support. How are you today? I'd like to go over an example that I think would be useful for people based on what a customer had asked if we can do. So this customer wants to basically have a measurement that is synchronized between two procedure activates. So he wants to tell the procedure to start recording. He wants to then be able to do as many independent things as he wants, and then he wants a procedure to say stop recording. So this is exactly how our time spectroscopy functions. So if you've used the data logger before, it's very similar to that. You set up a sample frequency and a maximum acquisition duration, and that's how long you have to acquire the data. And if you've acquired data that's less than that maximum time, it will truncate the data file for you. Okay, so the pieces you need to get time spectroscopy to work, we go to hardware space. If we type in time onto this item palette on the side, you'll see time spectroscopy. And this works pretty similarly to the other ramp spectroscopy items. So I've placed time spectroscopy, and I've placed a measure item connected to this. So the way the measure items work for spectroscopy, we have the top pin connected to our signal, which in here I'm just going to measure the input off the channel 2. The middle gets connected to the scan area window, like you can see here. And the bottom pin is what connects to time spectroscopy. Alright, so now once you have this stuff connected, and we have the AFM input set to spectroscopy, or image plus spectroscopy. If we go to spectroscopy, time spectroscopy is now available. Alright, so the next piece you'll need is the general shell for the procedure. So if you'd like, I can provide you with this time spectroscopy procedure as an example. So this looks like a general purpose spectroscopy procedure. We have some setup stuff here. We have some markers to set up the experiment. And you'll see here we have a forward high and a forward low. So everything that happens between that forward high and forward low is going to be recorded with the time spectroscopy function. So all I'm really going to do for this particular example, I'm going to take the bias, and before we start recording, I'm going to ramp it up to 1 volt. So once we start the procedure, or once we start recording, we'll have forward high. I'm then going to ramp the bias down to 0 volts over 1 second. I will then ramp the bias back up to 1 volt in 1 second. And then I'll end that curve. Now you'll notice I have this required delay after this forward low. That's just needed for timing purposes, so the software can distinguish between the different curves. So you'll see this lives inside of a loop, which is called spectra to acquire. So what this procedure is going to do, it'll first ramp the bias to 1 volt. It will then start recording, ramp us to 0 volts, ramp us back up to 1 volt, and it will do that 5 times. So you'll have 5 different spectroscopy curves in this data file. Now, also something I've added in the cleanup state, well, actually at the end of this procedure, you'll see the last thing I did here was returning the bias to whatever the dashboard already had for the bias. And I do that just by referring this dashboard panel to itself. So bias modulation value, and that's the bias modulation value. So right now it says 0 volts on the dashboard, so that's why it gives me 0 volts here. Now this other block on the side is needed in case somebody presses the stop button to abort the procedure while it's still running. So you'll notice these same things. You have the save, delay, spec low, stop history, just like you do here at the end of the normally running procedure. And the last thing I have is returning the bias back to normal. All right, so if you wanted to do something custom or special, what you would do is take this template and you'd you'd replace the setup VB with whatever initial setups you need before you start the acquisition. And then you'll replace these middle pieces where I had a sweep down and sweep up. You'd replace that with whatever you wanted, such as sending out your TTL pulse, sending out some extra signals, waiting a little bit so that it gets a response, and then you can set low so it's finished. So now we can run this procedure. And since I've called this time spectroscopy and given it the procedure type spectroscopy, it will show up on the time spectroscopy window here. Now, time spectroscopy, as I said, is similar to the data logger. You have a sample rate and a maximum number of samples, and that specifies your maximum sample time. For the experiment that I was doing, I was just ramping the bias a volt to 0 volts and then back up to 1 volt, taking a total of 2 seconds. So I know I want to record for at least 2 seconds, so just to be safe, I'll set a sample rate and maximum sample so that I'm at 5 seconds. And you'll see how this plays. In Spectra to Acquire, I'll set this to 5. So now when I run this procedure, it's going to download it. 2, 3, 4, 5. So it just ran that time spectroscopy 5 times. And as we see here, it went from a volt to 0 and back to 1. And I saved that file in the data browser. So here you can see curve 1, 2, 3, 4, 5. So as you can see, it's only going over the 2 seconds now because that's how much data I actually recorded. So it's very easy to modify the time spectroscopy template procedure in order to make it do a wide variety of different experiments. So if you have any questions or comments about this, or if you want to see the basic template for the procedure, please contact me at support@rhk-tech.com, and I'd be more than happy to help you out with this feature. Thank you and have a nice day.